Air is being pumped into a deflated spherical balloon. Okay, I'm going to pause right here. When I worded this problem, I wanted to be very cautious to demonstrate that the balloon began with a radius of 0. I think that's going to be important, so that's why I said deflated. At a rate of 2 cubic inches per second. Let's just stop reading and start writing. Air is being pumped into a deflated spherical balloon at a rate of 2 cubic inches per second. Okay, this is clearly a rate. A couple reasons. These units represent a rate. It's cubic inches per second, and they did say the word rate. But it's a rate of what? Is it the rate of the radius? Is it the rate of the area? What is it? Well, we're dealing with cubic inches, and that's a measurement of volume. So this is the volume of air, which is very much implied from the units themselves. Okay? Second sentence. What is the rate of change of the radius with respect to time? Of course. When 4.5 seconds have elapsed, and we'll just say that t is equal to 4.5 seconds. And we've just written down everything we know, and that's it. So let's read again and see if we can figure out what equation we're going to use. Okay, we're not dealing with the formula for the area of a circle because we're dealing with a spherical balloon that has a volume. So we need the volume of a sphere. So let's write that down. The volume of a sphere is 4/3 pi r cubed. Good to know. We're going to take the derivative of both sides with respect to time. The derivative of v is dv over dt. The derivative of 4/3 pi r cubed, so 4/3 times 3 would give you 4, and then pi, and then, because it's a constant, r squared. Yes, that looks like the surface area of a sphere. There have been papers that have been published about that very topic, about how the derivative of the volume of a sphere looks like the surface area of the sphere. But anyway, there you go. Let's start plugging in what we know. We'll find out what we don't know, and we'll probably find out there's stuff we don't know, but that's okay. We'll deal with it. So the volume is 2 cubic inches per second. 4 pi radius squared. I don't know the radius. Man, that's a shame. The rate of change of the radius, don't know that either, but that's what I'm looking for. Okay, so we're kind of stuck. We can't go any further with this until we figure out the rate of change of the radius. The radius itself. We can't find the rate of change of the radius until we find the radius. So let's find the radius. What is the rate of change of the radius when 4.5 seconds have elapsed? I wonder what the radius is. Here's the real question. What is the radius after 4.5 seconds? I don't know, but I have a wonderful way of finding out. We'll switch colors again, just for fun. We're gonna go back to this. Didn't we just do that? Yes, we did, but we did calculus with that. Now we're just gonna do some algebra, okay? I'm gonna find the radius. And I'm going to find the radius when given a volume. And I said I was given a volume. I'm actually not given the volume, but we can find it very easily. So the volume of a balloon that is increasing at 2 cubic inches per second for 4.5 seconds. Oh, so 2 times 4.5. That's 9. If I just threw a 9 on the paper, someone might say, where'd you get your 9 from? Well, there it is. So 9 equals 4/3 pi r cubed. I'm about to find out what r is. So let's do it. Let's just divide by 4/3 pi. Totally okay. And then r cubed will equal that. So I'm grabbing a calculator. And I wrote one thing. I'm going to type something different. If I wanted to solve this thing for r, I would multiply by 3, divide by 4, and divide by pi. And it's the same thing as if I did 9 divided by and then 4/3 pi. Okay, I'm going to get the same thing either way. See, this is that. This is me saying, oh, get rid of the division, get rid of the multiplication, get rid of the multiplication. It's that, same thing. And so r cubed is equal to this. You can write this down or not. If you want to skip this step, you can. So 2.149 is what I have. Now, I've said that in this class we always use 3 decimal places, but let's be careful. because using 3 decimal places can get us into trouble sometimes. I do not want to take the cube root of that where I'm pointing. I want to take the cube root of that because my calculator has a lot more accuracy. So I'm going to take the cube root of that. So we'll press math. It's under the math button, math menu, and we'll take the cube root of the last thing that we got as an answer. I'm just going to press up and retrieve that last answer. And there it is. So we now know the radius, and I'm going to write 1.290, and that's fantastic. But I'm not going to use 1.290. I'm not going to officially round what I'm doing until I'm done, right? Because I'll lose accuracy in the process. So even though I'll put in green 1.290 here, I'm not going to use 1.290. I'm going to use 1.290381021, and I don't want to write that over and over. So just in case you haven't seen it before, here it is. This is my radius, and for the rest of this problem, I'm going to call this my radius. But I want to store it in my calculator for all the other times I'm going to need it between now and the end of the problem, which isn't much, but it's handy to do. This button right here, we're going to press it. Stow. We're going to store our last answer as a variable. What variable? Well, I'm going to call it R for slightly obvious reasons. So I'll press alpha and then R, which mine is the multiplication key. And when I press enter, from now on until I've cleared my memory or reset R, this is R. So instead of 1.290, I'm really going to use R. So let's solve this. And when I solve it, I'm going to find out what dr over dt is. And I'm going to do a lot of this without writing it down, so just follow me closely. We're going to divide by 4. So 2 divided by 4 divided by pi. And then I would divide by this, divided by this. This is r, and it is squared. And we just stored r, so we just retrieve it. 0.0, whoops, 0.0, where's my whiteout? Messed up. 0.96 what? I don't know. Okay, what are we dealing with? The units work out quite nicely, but let's just put it in context and figure it out that way. This is the rate of change of the radius. A rate should have the word per in it, like P-E-R, not like a cat. But the radius should say, the rate of change of the radius will be a length divided by a time. We are measuring length in inches. Volume was cubic inches. Regular radius will be inches, just inches, divided by time, which in this context is seconds. 0.096 inches per second when 4.5 seconds have elapsed. Constant volume increase, and now the radius is changing at differing rates.